Okay, on to problem 14.2 here. What we're going to do with this problem is we are going to prove the Pythagorean theorem. So the first thing, Elena is playing with the equivalent ratio. She wrote and she rewrites the proportion a over x equals c over a as a squared equals xc. Diego did kind of the same thing and ended up with b squared equals yc, and that a squared and b squared reminds him of the Pythagorean theorem. Elena says the Pythagorean theorem says that a squared plus b squared equals c. I bet we could figure out how to show that. So question one is, how did Elena go from a over x equals c over a to a squared equals x times c? Well, we can see here that Elena knows that if a proportion is true, then the cross multiples must be equal. So really, all she did was cross multiply. So Elena simply cross multiplied. To get a squared equals x plus c. We'll put that equation in. A squared equals x plus c. A squared equals x plus c, or x times c, rather. All right. Next, moving down, what equivalent ratios of side lengths did Diego use to get b squared equals y over c? So if we go up here, we need to figure out which one of these proportions did Diego use, and we see that he used the middle one, b squared. If we cross multiply here, b squared is going to equal y times c. So that's what he used. Diego used b over y is equal to c over b. Okay, now what we're going to do is we're going to prove the Pythagorean theorem. All right, so this is going to be kind of long. I will type most of it, but when we get to the algebra part, I'll write it out. So here we go. We'll start. We know that in a right triangle that has an altitude drawn to the hypotenuse, the original triangle, the big one, is decomposed into two smaller triangles. All three of these triangles are similar by angle-angle similarity. Okay? And we did that last class. Since the triangles are similar, the side lengths, the corresponding side lengths, are proportional. So, now here's where I'll start working with the algebra. We know that a over x is equal to c over a, and we know that b over y is equal to c over x. C over b, rather. Okay, what I'm going to do is I'm just going to cross multiply these. And we got a times a is a squared. And that will be equal to x times c. And I also know that b times b, or b squared, is going to be equal to y times c. Okay? If we add these two, we get a squared plus b squared is equal to, and then it's, instead of writing a squared, I'm going to write xc plus, for b squared, yc. Okay, come up here. So now we have this equation. A squared plus b squared is equal to xc plus yc. Now I'm going to focus on the right-hand side here. And I notice, looking at this, that I have a common factor of c. So I could take that common factor of c and I can write it on the outside. Okay, notice how I just undistributed. I undistributed that factor of c. Okay, so now I have this a squared plus b squared is equal to c times, well, I wonder what this x plus y will equal. If we go back to our original triangles, notice that my x plus y, that length, equals c. Let me make this so we can see. Notice up here at the top, this x plus y is equal to the length of c. Now when we come back down here, we have the Pythagorean theorem, a squared plus b squared is equal to c times c, which is c squared. So we've just proven the Pythagorean theorem using similar triangles.